Hello everybody, I'm Alex. I know it's the last talk of the first day. I'm probably tired, there's no more mate left. But stay with me for 30 minutes and I'll give you web performance optimizations straight into DevTools. When I pitched this morning, Karma said I'll pick a talk from the audience. I haven't changed my mind, so if someone wants to volunteer a website they want me to take a look at, don't be shy. I'm sorry? Do you want to come on stage and spell it out for me? I'm happy to do that. Right, it has to be PG-13. The whole website has to be PG-13. Right, go for it. So I do a bunch of things in this world. I volunteer for Mozilla as a Mozilla Reps and Mozilla Tech Speaker. You've seen a fellow tech speaker come up on stage today and talk about his Dance Revolution. But I like the idea of a paycheck, so I also have a day job as a JavaScript developer advocate for Nexmo. Anybody heard about Nexmo before? Okay, 2 people. That's still good. They did cloud communication APIs. I'm not going to talk about that. I'm going to talk about web performance. And when we talk about web performance, most people focus on JavaScript optimizations. And that's kind of sad because web performance has like 3 stages where JavaScript optimization is the very last one of them. So whatever you do to optimize your JavaScript, it's still going to be micro performance optimization if you don't optimize the first 2 chunks. We're going to look at all of them. We're going to open up DevTools on the website. And I'm going to power up 3 of the tools I'll use. One of them is network, the other one is memory, and the other one is actual performance. So let's take a look at the very first one. Let's look at network, because that's when you want a website into your browser. What's the first thing that happens? It goes to a DNS, tries to look up what you want, and then is this just images? No, it can be. Right, okay. So it looks up what you want out of the website and it starts bringing it in. So if I look at that, I'll see, as soon as it loads, I have a bunch of images that start loading after the JS files load. Now I can look at each one of those requests individually. I'm not going to do that. I'm going to look at the ones that are problematic. This is one of the really optimized ones. So for example, I'll look at this. When everything took 33 milliseconds, this JavaScript file took 500 milliseconds. That's huge. All in all, I had 91 requests with 3.5 megabytes, but only 1.6 of those was transferred. And that's because probably the website has something like JZipping. So I get 1.6 megabytes, and then it expands on disk. I don't really care about the actual size on disk. I care about the transfer size, because that's what comes through the network to the browser. So I'm going to look out of those. Oh, it still loads. It says it finished in 30 seconds, which can't be right. So that means it's still loading. I'm going to look at the big one. So if I look at it, I can see it's JavaScript. I can see content headers and a bunch of other stuff about it. I don't really care. The token is strangely small, but what I really care about is the timings. Because when you ask a resource from the internet, the reason it says blocked right there is because the browser can't handle all the connections your website wants to make. It goes and does DNS resolution first. It starts connecting to the IP. It does the TLS setup. It sends the little bit of data that I want back, and then it waits for the server a really long time, and then the server sends back that micro JavaScript thing. And if you look at this, the things I can't really touch or optimize are the DNS resolution. I don't really control where the DNS comes from on the client side. The connecting bit, that means your server is halfway around the world. Your IP is halfway around the world. You don't have a CDN I can connect to. You don't have something that's close to me. For example, if you're using EU West or whatever, that's Frankfurt, it should connect in a millisecond. The TLS setup, I can't really influence a lot about that. It's just, it has to do with your connection the same way. So if your connecting is going to take long, your TLS is going to take long because it just connects a bunch of times to the same thing. The sending part is instantaneously because I'm not sending a lot of data. If the sending part was huge, that meant probably I was sending form data or something on the network. And then I wait for the server, like for at least a quarter of the time. And that means your server isn't fast. The server has too many connections it has to handle at the same time. And the receiving bit is instantaneously. The things that I really care about are the sending and receiving, and those happen fast. The thing your user sees is, wait, my browser blocked my HTTP request because there were too many in the queue. So depending on the browser, there's a limited number of connections. And how do you resolve that? Instead of loading, when I started, it loaded like 20 images out of 90 requests or something. Make that 1 or 2. I won't see them anyway. They're above the fold. Why do I need to connect and get them before I get your JavaScript? If it's JavaScript, I've got somewhere in there I can see the JS request, 19 JavaScript requests. Why can't you make one as JavaScript? The file it's in, it doesn't really matter. So compress all that into one. Minify it. If I look at CSS, CSS looks better and it looks like only one is from your domain and the other one is from Google. That kind of makes sense. You can't, unless you get the Google fonts in locally with your CSS, then you can make one request. I'm going to look at images, which is the bulk of it. Why do you need to send me 65 images from the load time? I can't see 65 images on the page. Send one, send two, sprite them if you have to. Send a bigger chunk. You don't lose on connection. Because if you look at the server timing, you can see the stuff I'm waiting for just to go and connect to the IP. Every image takes just as much time for that, and then it sends 4 kilobytes. I probably lost more time on the connection than on the actual transfer of those 4 kilobytes. Sprite it with something else. Or for this, I want to see what's a 4 kilobyte image. Right, did you really need this to be an image? It's 4 kilobytes. So if you look at this, this is the big part of performance, the first part of performance. Because no matter how fast your website actually runs on the client, it depends on the time it takes to get to the client. And any React fans in the room? Right, okay, yeah, you're not gonna love me. The last time I used Create React app, I had 20 megabytes of JavaScript. Why do I need 20 megabytes of JavaScript? Don't get me wrong, once it actually starts, it's fast. I'll give you that, React is fast. But just the fact that it's big makes the user load experience more than 2 seconds. There's a bunch of papers online that say, if your website loads over 2 seconds, you're gonna start losing users. I wouldn't advocate for 2 seconds because a bunch of people read the 2-second rules, and some of us might have been forced to slow down our websites to load around 2 seconds instead of milliseconds, just because if it's instantaneous, your user's gonna think, oh, it came from cache, it's not fresh, let me do shift refresh on it. But I'd advocate in under 3, somewhere in between. And that means you have to get everything in one go, so you don't keep doing the round trips. Every time I do this, and every time I look at the website, most of the times fixing this means more server resources. I know you'll think, oh, it's the client, it's cheap, we can do whatever we want. Sometimes it's not cheap. Sometimes having to transfer 3 megabytes of data actually costs me money, and you're gonna be upset on your website. So you want your users to be able to say, yes, this loaded fast for me, and so on. So this is the first part. The second part is the performance tab. So you've got everything to load on the web page, or you got it from the internet on the page fairly quickly, and that's when performance starts to actually, you can start to actually see performance, because once you have the resources, the browser is going to start rendering them. The connection is 1 bit. As soon as the first resource hits the browser, it's going to start rendering them and doing stuff with them. And that's when you see performance. Now, the way performance works is you've got to record it, make a snapshot of it, and kind of debug on the snapshot. Because no website loads the same twice in a row, I don't think even a just HTML page is going to load in the same timings twice in a row. Some people say 3 snapshots, some people say 7 snapshots. I'll just do 1 because I'm lazy here. So I'm going to record performance. I'm going to scroll around for a bit. And then I'm going to shift refresh my whole thing. And I'm going to stop recording. So you see, in terms of the website, it's not really a big deal. Is this like weddings website? Category page. How do I do categories? This a category? Yeah? Okay. So I'm going to throw this away. I'm going to start recording performance. I'm going to scroll. And then I'm going to shift refresh. Is someone going to get fired over this? Are the developers actually in the room? Right. Amazing. Yes. I'll take it easy. So you see the difference between this and the first page. The first page, I did this performance recording and I was 1% buffer full. I did the same thing on the category page, I was 8% buffer full. And that's because the browser can only handle so much happening at the same time. When you do performance or memory, you're taking a toll on the browser. Network maybe, but not so much. You're taking a toll on the browser. So it's actually, Firefox is actually going to show you this takes a toll. Right, so I'm going to look at what I did. I started scrolling for a bit, and scrolling didn't do a lot of things for me. They're color-coded. I can't zoom in any further. So the whole thing is color-coded, and it shows me purple as style changes, and that means I scrolled a bit, some more stuff came into view, I hovered over bits, and then the styles had to change for it. It's not really a problem, except I've got a ton of them. And that means out of those CSS, out of that CSS file, you've got a lot of competing rules, or you've got a lot of things that change state based on where my mouse is. And that's why I see a bunch of recalculating style. I actually only see 1 paint in the whole thing, which is good. So the way this happens is once you start changing things with JavaScript that have to do with CSS, it needs to repaint the browser instead of just recalculating style, because you basically said, I have the CSS style, work with it. And then you start scrolling about and things happen, but as soon as you tell it from JavaScript, look, there's this new rule for it, it's going to have to do a repaint because it doesn't understand where to put that in context of the styles. So that's actually good. It's better than most websites out there. There's some websites that in the paint category you get, right, the paint every few seconds, and that's because you interacted with JavaScript on the DOM. There's a bunch of DOM events in here, or I just hovered on it. So there's a bunch of DOM events in here that trigger repaints on the browser. Now I'm gonna look for it. It's just, this is me scrolling. DOM events and styles. How do you fix that? How do you stop me from triggering recalculating style and DOM events? Do you really need hover effects on all buttons? If you do, I'm sorry, it's gonna take a performance toll. If you don't really need to put them in. I wanna look at the page to the point where I think I refreshed here. Right, so this is where I started doing the refresh. What my browser understands by that is, right, let's keep the page I was in sort of a dead zone, ready to decommission it, and let's show the new stuff. But the decommissioning bit means all your JavaScript that's in there is taking a toll, and technically, when you're doing refresh on your website, only your website suffers, but most of it is going to be, oh, the user navigates on a new page. So it actually you're making the next page a bit slower just because I've got JavaScript trying to dump the garbage collection, and it's trying to do it non-incrementally. And it's basically saying, I don't really care, just dump, 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 and it's going to block the thread for a bit. And then after I did that, it started loading the new bits, and the new bits come with style recalculations. I don't understand why I do function calls, and that probably means your JavaScript starts doing things as soon as it hits the page. Do I want to know what's it built in? Do I want to look under the hood? Or are you going to tell me, is it React? No, thank God. Right, so it still means your JavaScript starts doing stuff to the page as soon as it loads. The timeout bits are the ones that keep popping up. Let's look at what so if I actually want to see what's the offending piece of code, I can. Every event has something tied to it. And this, for example, once I clicked on it, it opened the debugger for me, so I can look at the line of code, and that's, I set my script as loader config, whatever, I loaded something, and that's the piece of code that made that specific trigger. If I go back to it, I can look at what made the DOM event. That's the load DOM event. That means the DOM event loaded page triggered. My only problem with it, I see it twice, so that means you finish loading it and then you did something more in JavaScript and it loaded again. I strongly advise you to do DOM loaded just maybe once, because it's enough. And whenever you do loaded and loaded, it's going to start doing recalculating style, because it's going to figure out, I missed something, let's panic and do it again. The new browser engines are a lot better at this. If this isn't your thing, this is kind of hard to visualize, because you see the type of events, and I can see most of the events have to do with the DOM in the first part, because I scrolled around a bit. And the second part, it's just doing stuff, stopping, doing stuff, stopping, doing stuff, stopping. That means you're lazy loading something using JavaScript. And this, you're getting a good frame rate per second, which is like 50. Anything between 30 and 60 is acceptable. Anything under 30 is not. If you're doing games and stuff on the web, you really want to go for 60, or video, stuff like that. You can visualize this whole thing in different ways. So you can see it as a call tree, and it shows you, let's see if I can make it bigger. No. Maybe. So you can see every piece of JavaScript that interacted with a page, or every piece of code in a tree-down view. So you can see what's down to the level of, right, this is my most offending function that takes the longest. It's a single one. It's pdp.js. I don't know what PDP does. But you can figure out, right, that's my problem. I'm going to focus on this. One of the other things that the flame chart is, if you want to see it and see, this is probably like you can figure out where I did refresh, because this was linear, and then it started doing a bunch of different things at the same time, and that's basically the point where I hit refresh. Regularly, your page, once it loads, it's going to do stuff linearly, and that styles JavaScript and stuff like that. If you see this, it means you're doing either a single page app that hits the network every few times and it's refreshing the view, or you just reloaded the page. So I told you this was the recording. One of the things that I find cool about the performance inspector is you can actually import. So if you do this in a team, which probably most of you probably are, if you care about performance, or if you get to that point with your app where performance is an issue, probably have a big team. It's really hard to work on performance in a team, just because your recordings are going to show something, and your teammates are going to show something slightly different every time. But with the import feature, so you can save this recording and use that as the baseline for the entire team, and then you can all work on the same data instead of having to, oh, I created slightly different data, problem. So network and performance. Performance has to do just a tiny little bit with JavaScript. And it's mostly, my JavaScript is triggering out other events, or is triggering out other stuff. Or it's, oh, I need to garbage collect. What happens when you want to go down to JavaScript level, to function level, to see where it eats up memory? This is the memory tab. Works kind of the same way, except you don't record your memory. You take a snapshot of it, so you don't have to record anything. It's going to go and grab as much memory as it can, and then figure out what the memory is used for. So if I look at this, I took a snapshot, and I can see visually, I can see where my memory is going, and that means my DOM nodes do 5 megabytes of memory. That's not a lot. With about 5,000 DOM nodes. Do I want to know why I have 5,000 DOM nodes? And that means whenever you create a new element or whenever you hide it and close it and stuff like that, it interacts with DOM. Whenever you change the properties on it, a new DOM node gets created in memory. And probably on the page you have close to 200, 300 maybe. But it means in memory, every time you do something with those 300 nodes, they get multiplied and multiplied and multiplied. You strangely have 2 documents on a page. Most websites have 1. And that means you triggered the DOM loaded event. That means you triggered the DOM loaded event twice. So the first document that was loaded was saved in memory, but then when you loaded the other one, it said, oopsie, I need to create a new document for you, so you have both in memory right now, even though one isn't doing anything. The scripts is the next big offender after that. So this is zoomable, so you can see exactly what scripts are taking up most of the memory. I'm going to look at the biggest one. The lazy loading pdp.js, the ever-offending pdp.js, that's your biggest one. And then the just-in-time compiler is eating some of that memory up as well. Apparently, you've got no file name. That means you have inline styles somewhere in your HTML that are eating up part of the page. The Google Tag Manager, that usually shows up. If you want analytics are going to be a big chunk of your script. And then you've got objects. It's a given. You work with JavaScript, it keeps object in memory. Most of the time, it's functions and objects that you have problems with. But if you go down the stack, you can see, for example, if you're regular expression heavy and stuff like that, it eats up the memory. The strings, that's not really important. Everybody has strings. You could probably cut it down with using less spaces in your HTML and stuff like that. The other is interesting, though. You've got weird stuff that the JavaScript engine is doing, like object group and shared and shape, which the profiler doesn't know how to interpret. It comes down to you using custom classes in your JavaScript, and that get bundled up into other. So I've showed you how to do network performance to get you as fast as possible to a client, rendering performance on top of other things, and then memory performance. The only part where JavaScript actually matters and your micro performance optimizations matter are in here, which you're not doing too bad. If you look at a different website, mine has minimal JavaScript. I think maybe 100 lines. And of course, DevTools failed. Why wouldn't it? It's a live demo. So if you look at mine, you can see my script is actually smaller than my strings. It's minimal, but I have my DOM nodes are big. And this is a static website with maybe 100 lines, 100 and something lines of HTML tops. And it still shows as 763 count, whereas yours showed 5,000. And you can look at the stuff you can improve. If you want to go down to actual JavaScript performance, let me start the performance bit. Right. So if you want to go down to JavaScript level, you can. But your browser, DevTools, isn't the best tool for it. Like network performance and memory are not the best way to trace all your JavaScript. I actually think the console is the best way to trace your JavaScript, but I'm running out of time. Running out of time? Yeah, I'm running out of time. So I'll stop here for a bit. I think the console is the perfect way to basically debug your JavaScript. And there's two things in the console API which help you a lot, and that's console.time and console.time end. And that takes you how long your JavaScript took to execute, or how long it took between these points in your execution. And the other stuff is console.trace. Console.trace isn't going to work because I have an anonymous function in here. But console.trace shows you every function you had to pass through or skip through to get to the point you're at now. And that means this function gets called at the first level, at the second level, and at the 7th level of my execution. This is the thing I'm going to optimize first. If it's one of those, oh, this thing actually maybe gets called once every blue moon, I'm not going to optimize that. I'm going to stop it here. If you have questions, now's a good time. I think I still have like 2 minutes for questions. Yes. A site with everything perfect. Yes, it's a blank page. No, the whole point of performance optimization is you optimize. You can't make it perfect. You have to make trade-offs every day. Do you want images? Images are usually big. You need images for your website. Is this business critical? Well, it's going to be big. At least you can load them either five at the same time, all in one, or you can load them bit by bit with streams and stuff like that, or via WebSockets. Keep a connection alive if you're doing 7 images. Do HTTP keep alive and send 7 images on the same connection instead of having to renegotiate the same connection over and over and over again. Cool. Any other questions? Yes. The marketing script. Right, so scripts are usually static. Even Google Analytics. You can download Google Analytics, run it, bundle it with your own script. The problem with the script is usually, well, you need analytics, you're going to live with Google Tag Manager. You saw that was a chunk. It's one of the trade-offs. You want it hyper-performant, you give up analytics, which I wouldn't do. To be honest, I wouldn't do. I like analytics. I like knowing how my website performs outside of my little bubble. I wouldn't trade it for that. But the 17 that you can change, because it's probably 3 external and 17 that you make. The 17 that you change, that's the bulk of your performance optimization. Nobody says you can make it perfect, but you can take care of the stuff that you can influence. For example, you don't control the hosting, or you have to go to DevOps to control the hosting. It's not really a front-end developer's job to control the hosting or the server you're running in, but it's something you can see and you can debug. You don't have to necessarily fix it. You can have someone else fix it, but you can say, hey, this is a problem. And I think that's time, and I'm going to thank you.